Now we're going to learn some new things, properties of logarithms. We have to have positive numbers. If you go back to your graph, your basic graph of your logarithmic graph, remember the domain was from 0 to infinity. That's only positive numbers. It cannot even include 0, so that's why m and m have to be greater than 0. So we have a product rule. I want you to think about your exponents. Remember, if we have x squared times x cubed, remember how you kept the base and added the exponents? And since logs are exponents, pretty much the same. So you have two logs added, you can multiply them. You can also go backwards. We have a quotient rule for exponents. Remember, x to the fifth divided by x squared. Keep the base, subtract the exponents. So subtraction and division. That's how that goes together. Then we have the power rule. That kind of relates to this rule. Like if we have x squared cubed, we multiply those exponents. This is how this power, it's not quite exactly looking the same, but it really does come from that rule. So if we have a number multiplied times a log, we can move that number as an exponent. Remember, we can also go backwards. So we're going to use these properties to expand each expression, meaning you should have lots of logs, all right? We're really going to go, if we take these properties, we're going to kind of go from this side, the right side, to the left side. We have the log of a lot of stuff. We have division, so I'm probably going to use the quotient rule. I have multiplication, so I'm going to use the product rule. And I have powers, so I'm probably going to use the power rule. So let's just get started, one step at a time. Right, so we can write this, since the division, we can have log base a of 2 times the square root of p cubed minus log base a of qr to the fourth. So got rid of that division using my quotient rule. Something divided, I can now subtract them. Now I have these two things multiplied together, so I'm going to use this rule. So I have log base a of 2 plus log base a of p, and if y'all don't just follow this, this is going to be to the 3 halves. Remember that square root is the half. You'll see what happens. Now be careful here. I'm going to minus this whole thing. So this is log base a of q plus log base a of r to the fourth. That minus has to distribute to everything. Alright, we're expanding. Remember, we're expanding. Can we use this rule? Yes, we can. If you have exponents, you can move them down in front as a coefficient. So I'm going to do that here, and I'm going to distribute the minus sign. So I have log base a of 2 plus 3 halves log base a of p minus log base a of q. And then it's going to be minus 4, that comes down in front, log base a of r. We have expanded it as much as possible. Yes, that's ugly. It's just practicing those rules. Let's look at that next example. You have this big radical. When you see radicals, just like over here, you need to rewrite them as exponents because we're dealing with logarithms, which are exponents. So let's rewrite this as log base a of u squared v cubed all raised to the 1/5 power. Now at this point we have choices. We could actually use our laws of exponents and multiply those and rewrite it, or I can use my property of logarithms. Kind of doesn't matter, but I think it makes it a little bit easier if I go ahead and multiply my exponents. So this is u to the 2/5 divided by v to the 3/5. So I've taken care of that. Now I just have the log of two things being divided. So I'm going to go back to my quotient rule. So I can rewrite this as the log of the numerator minus the log, yes, I should put my base a, or whatever base you're in, of v to the 3/5. Now I can use my power rule that says I can take these powers and move them and make them coefficients. Oops, I moved it. That shouldn't be there. Minus 3/5 log base A of just v. Almost forgot what I was doing. Alright, so we're taking our exponents and moving them as coefficients, and that is expanded as much as possible. Now we're going to go backwards. We're going to squeeze. Alright, it's kind of like an accordion. So if you think about what we did on the last step, is that we took those exponents and moved them as coefficients. So since we're going to go backwards, any coefficients are now going to be written as powers. So this is log base A of x cubed, and I'm just going to go ahead and keep that negative, it makes it a little bit easier, log base A of y squared plus log base A of z to the 3/2 power. Now working left to right, addition and subtraction, what do those first two have? They have a subtraction, so you can combine these into a single logarithm by our quotient rule, rewriting it like this. Then we have two more with an addition, so that means we can combine them one more time by multiplying. So I have log base A of, and this is like z over 1, so this is going to be x cubed z to the 3/2 over y squared. I would leave it like that. If you want to rewrite that as a radical, go ahead. Don't need to do that for me. Alright, so I have coefficients that are going to move as exponents. That's really all I have. So this is log base A of x squared Now look at this example. You cannot distribute a logarithm. We have no rules that say that. So this is just the log of x minus 3. But we can express it as a single logarithm. These two have pluses, so I can multiply them together. So this would be x squared times x minus 3. Now if you want to distribute your x squared, you can. That would be alright. I'm not. Now I have these two with a minus sign, so our quotient rule says I can divide them. And that would be my single logarithm. So one more time, looking at your properties of logarithms, we have a product rule, a quotient rule, and a power rule. The good news is that's the only three properties we have of logarithms. They're going to come in handy to help us solve equations.